compositions. So this is another operation on that can be performed on functions and algebra operation. It just has its own section. So it was mentioned back when we covered operations. I told you it would be covered later. So here it is. So here is your composition. It's a little like looks like an open circle right here in the center. So be careful not to get this mixed up with multiplication. Multiplication is a single dot. And y'all don't usually prefer the composition notation, so my suggestion to you is anytime you're asked to do a composition, change it to the substitution notation. A composition is the substitution of a function into another function. Okay. And the f with the open circle g, that is read f of g of x, just like a function is f of x, it's f of g of x. So first one, we have two functions here, f and g, and we are asked to find f of g of 3. So f of g of 3, first thing I would do, change to the substitution format. So the functions f and g stay in the same order. F is on the outside and g is on the inside with the 3. So anytime it's the composition of an actual numerical value, I go off to the side rather than trying to do this all at once. So I'm going to go over here to the side and calculate the inside of the function. We work our way inside out on a composition when we've got numbers involved. So we're being asked to plug in 3 for the function, for x in the function g. So that would be 4 times 3 plus 1. And that would be 12 plus 1, 13. So then what we're going to do is we are going to go replace 13 with the g of 3. So this 13 now is going back in for this rectangle. I would like a curly arrow, please. There. Oh. One more try. There we go. So we know that g of 3 is 13, so we can come back over here and replace g of 3 with its actual value, 13. So now we can go calculate the outside, f of 13. So that means plug in 13 for the variable x. So that would be 2 times 13 minus 3. Oops. 2 times 13 is 26. 26 minus 3 is 23. So that means f of g of 3 is 23. All right, next one. This time we're given the same functions that we just dealt with in example 1, and we're asked to find each function and give that function's domain. So a little different here. Notice it's just an arbitrary x. That's when we know we're finding a generalized function. But it's still the same idea. Change immediately to the substitution notation, keeping the functions in the same order. So f is the outside function, g is the inside function. So it's the same idea as what we just did. It's just we can't do it off to the side to simplify because there's no value to calculate. So the inside is g of x. So what this means, f of g, is that we are being asked to take the entire function g, which is this 4x plus 1, and substitute it in for the variable in the function f. So over here where the x is in f, we're going to get rid of that x and put the function 4x plus 1 in its place. So we're going to get 2, and then I'm going to leave a set of parentheses because that's where the variable was, minus 3. So I have my function with a hole left where x was, and the function g, 4x plus 1, is going in its place. All right, so let me distribute. It's going to be 8x plus 2. And then 2 minus 3 is a negative 1. So this is our function, which I called p of x, or you could call it f of g of x. So there's our function. All right, we were also asked to give the domain. So remember, domain, denominators, square roots, and logs. So if we look at our function f of g, it has no denominators, no square roots, and no logs. So that means the domain is going to be all real numbers. B. Let me get the functions over here so we can see them. So we had f of x was 2x minus 3. And g was 4x plus 1. All right. So for part B, there's the function so we can see them easily. We are looking for g of f, so notice the functions are in a different order. Same as before, substitution notation. So f is inside, g is outside, so that means this time we are being asked to take the function f and plug it in for the variable on the function g. So we're going to take everything that is in the function f and over to g where this x is. I would like a curly arrow, please. We're going to plug in all of it where this x occurs. So I'm going to get my template for g set up, 4, and then I'm going to leave a hole or bubble, plus 1, and then I'm going to go get f and plug into its place. F was 2x minus 3, so we're going to plug it in. All right, distribute, 8x minus 12. Combine the back two, so we get 8x minus 11. So I called this h, or you could call it g of f. All right, so we were also asked to give the domain here. So if we look at our function, no denominators, no square roots, and no logs. So no problem, I'll write it in, let's see, I'll do the infinities here just so kind of review different notations. But again, it doesn't matter which way you write it on here. So one main thing you want to realize is notice, look at the two functions we calculated. They both involved the same function, but they did not give us the same answer. So the order is really, really important as which way the composition goes. Next. All right, f of x is 1 over x minus 2. G of x is x squared minus 4. And we're asked to give each of the following in the domain. So for h, we're looking for g of f. First things first, I don't like this notation, substitution. G outside, f inside. So we're taking the function f and subbing into g. So the function f here over into the function g. So where this x is, that's where we're going to put our function. So I'm leaving a hole, squared, minus 4, and in that bubble, we're plugging in the function f, which was 1 over x minus 2. All right, so when the functions start to get more complicated, you probably, if you are asked for the domain, I would go ahead and do the domain first. That way you don't have to worry about simplifying the function and losing something. So domain, remember, issues with domain are denominators. So I'm going to come over here on the side for the work for the domain. So if we look at this function, we have x minus 2 sitting in a denominator. The square on the outside has no effect on this, because the x minus 2 is going to be in the denominator whether it's squared or not. So x minus 2 is not allowed to equal 0. We add 2 to both sides. X cannot equal 2. So the domain, however you like, x can't equal 2. All right, as far as the function goes, if all you need is the domain, you're done. There's no reason to simplify this function. So it's just going to depend on the directions. If it does say to give the function, well, we got to do a little bit of algebra. So we're going to go ahead and simplify it. But just keep in mind, this may not be necessary because we have the domain without doing this. So I'm going to draw a line here just so you know that the rest of this is for simplifying. All right, first things first is that exponent. Exponents can be distributed on multiplication and division. So that means it's going to go to the top and to the bottom as a group. So 1 squared is 1 over x minus 2 quantity squared. And then we have our minus 4 here. So as far as simplifying functions, a lot of times we like to leave them in factored form because they just look better. So if I were simplifying this, I do need a common denominator. This 4 is over 1 right now, so it's not going to do us a whole lot of good. So I've got to make its denominator the exact same as the other, which means we are multiplying on top and bottom of this negative 4 by x minus 2 quantity squared. So that's going to give us 1 over x minus 2 quantity squared minus 4 times the x minus 2 quantity squared over x minus 2 quantity squared. So you can see their denominators are now the same. So that means we can write it as a single fraction. We also need to do some algebra. So I'm going to have one big division bar with my denominator left in factored form. So first thing we got to do is take care of this square. Remember that square means multiplied by itself 2 times. So I'm going to get rid of that 2 and write it twice just so I can run FOIL a little bit easier. All right, first outside, inside last. So x times x is x squared. Outside, negative 2x. Inside, also negative 2x. So that's going to be a negative 4x. And then last, negative times negative, positive 4. Then, I'm running out of room. We can distribute our negative 4. So it's going to be minus 4x squared plus 16x minus 16. All over, same denominator. And then we can combine the first and the last. I gotta go sideways, I'm out of room. So we have negative 4x squared plus 16x, and then the negative 16 plus 1 is gonna be negative 15. Minus 2. And the denominator you could multiply out or you could leave it. It should not matter. There's really no reason to multiply all of that out. So only simplify if it asks you for that simplified function. So we'll label it this is the simplified. All right, simplified function. Next, let's go get our functions, f and g, 1 over x minus 2. And g, x squared minus 4. All right, f of g, so this time, g is inside with the x and f is outside. So we are taking the function g, all of it, and plugging in for our variable on f. So where this x is, all of that's going to go in its place. So I'm going to get my template of f set up. F was 1 over, and then it was our variable, so my bubble, minus 2. And inside of that bubble goes the function g, which is x squared minus 4. All right. So, domain. We can go ahead and do domain. So I'm going to come over here to the side. All right, so denominator. We do have a denominator. We pull everything in the denominator, x squared minus 4 minus 2 cannot equal 0. So these parentheses are not necessary on this problem because there's no exponents or distribution that's got to occur. So we can drop them. And then we combine like terms. Negative 4 plus negative 2 is negative 6. We add 6 to both sides. Squares by itself, so then we can square root. Don't forget your plus or minus. So x cannot equal positive or negative. 6 does not square root nicely, nor does it reduce, so that means we leave it alone. So the domain is x can be anything excluding positive and negative square root of 6. All right, for our simplified function, so again, I'm going to draw the line just in case, because if it doesn't ask for the simplified function, there's no reason to do this, because domain's already done. So for our simplified function, again, parentheses we said were not necessary, so I'm going to drop them. So x squared minus 4 minus 2. All we can do here is like we did with the work for the domain is combine those back two. So that would be x squared minus 6, because this one doesn't factor, so we would leave it alone here. So again, this is simplified. All right. Next. All right, example 4, two functions f and g such that f composed with g of x is 3x plus 2. So this is going backwards. It's giving us the composed result, and it's asking us what the original functions f and g could have been. Now, the key thing you want to remember with this is there are infinitely many ways to decompose functions. Okay, so work on my spelling here. So because there are infinitely many ways to decomp two functions, if you're given choices, check those choices to figure out which one is correct. Okay. So we don't have choices here, so we gotta go through the work. So first thing I'm gonna do is rewrite with the substitution notation, just so I can see it a little bit better. All right, so we're gonna go over the two easiest ways to decomp, and then we'll go over a little more detailed. So I'm going to list f of x as a choice, and then I'm going to list our g of x as a choice here. All right, so the easiest way to decomp two functions is to call the outside function, which in this case is f, call it x, and call the inside function, in this case g, exactly what you're trying to get to, 3x plus 2. So when we take, so to check the decomp, you can see I would take the inside function g, plug it into the outside function f, where the x is, and it is going to give us 3x plus 2. Another way to decomp is to reverse that. So I'm going to call the outside function 3x plus 2, and I'm going to call the inside function x. Okay? So that when we take the function g, and we sub it in for our variable on f, we get the same thing, 3x plus 2. So those are the easiest two ways to decompose functions. So now we're going to get a little more detailed. I'm going to call g x plus 1. So for f, the idea with f is I've got to get 3x plus 2 out of it. So I know that g has to go in here. And I know somehow I got to get a 3x plus 2. So that right there tells me I have to have a 3, because the only way to get 3x is to multiply x by 3. So if I multiply this 3 through, let me scooch this up just a little bit, because I'm going to do a little bit of work. I'm going to scooch you up some more. Okay. So if I distribute that 3, that is going to give us 3x plus 3. Well, we don't want 3x plus 3. We want 3x plus 2. So I've got to figure out what to add here in order to turn it into 3x plus 2. So in order to take a 3 down to a 2, a positive 2, I've got to get rid of 1, which means I just subtract 1 at the back here. So if I use the function 3x minus 1, I will get what I need. Again, let me scooch this up. So again, this way is a little more involved. So then we just pull those characteristics. So I pull my 3. Remember, this was the variable x, and then minus 1. And then that's where you get into the addition subtraction game. I could turn g into x plus 2. Well, then I would adjust f. I could turn g into x plus 3 and then again adjust f accordingly. That's where you get those infinitely many options. So it takes a little bit of practice to figure this out. So if you have an open-ended choice, I would choose one of the first two methods. If you're given answer choices, like different options, just compose them and see which one gives you back the original. All right, next. All right, p of x is x minus 4, b of x is x squared minus 1, and j of x is x minus 3. Find the function and give the domain. So this is just kind of bringing back the operations we covered way back towards the beginning of the semester, just to show you they could be combined in one. So here we're being asked to divide and compose between the three functions. So first thing, same as always, I don't want to use the comp notation, I want the substitution notation. All right, so it's b on the outside, j on the inside. So two things here, one division, so p is not involved in the composition, so I'm just going to go get it. P was x minus 4. So x minus 4 goes in on the numerator. Then we have the composition on the bottom, so we're being asked to plug the function j into the function b, and then all of that goes in the denominator. So the function j is here. The function b, we're going to taking j, it doesn't like when I'm too close to the top. There we go. And replacing it where that x was. So that is going to give us, I'm going to get my template set up, bubble squared minus 1. So bubble, it's a terrible bubble, squared minus 1. And inside my bubble goes the function j, which is x minus 3. Right? So here's our function. So here's the unsimplified function. I believe it said domain. Yep, domain. So we're going to go do the domain first. So off to the side. We have a denominator. It cannot be 0. So x minus 3 quantity squared minus 1 cannot equal 0. So we want to be careful with this. That is a square. You cannot distribute an exponent along addition and subtraction. Instead, we need to multiply out. All right, so first outside, inside, last, x times x. Then we got outside, inside, negative 3x, and another negative 3x, so negative 6x. Last times last, double negative is a positive, 9. What do we get here? Combine like terms, x squared minus 6x plus 8. So I got my slash. Cannot be 0. Hopefully this thing's going to factor. So let's try double bubble. All right. So then we have split the front, x and x. Split the back. So I need two numbers that multiply to 8. I'm going to try 4 and 2. If that doesn't work, we also have 8 and 1. And the goal is to add to negative 6. Well, 4 and 2 add to negative 6 if they are both negative, and that works good because I needed the positive 8, and that's going to give us the positive 8. So then x minus 4 cannot equal 0, and x minus 2 can't be 0. Add 4, and add 2. So we have two issues here. So our domain is excluding both of these, so you could just say it cannot equal 2 comma 4. I am going to do the interval notation just to review that one because I don't think we've written it that way yet. So throw out the 2, jump it, and then jump the 4, and continue to infinity. All right, so if you're asked for the domain, we don't have to simplify the function. If you do have to simplify the function, the nice thing is the work we just did for the domain is going to be that simplified denominator. So our function is, we've got the x minus 4 over, I can just go get the factored form of our denominator here rather than just repeating all of this algebra twice. Just pull the factored form over here, x minus 4 times x minus 2. And then if you look closely here, notice our numerator in factored form is the exact same as our denominator, or one of the factors in our denominator. So that means that these two are going to divide out and be gone. So those two divide out. Anytime you lose an entire numerator, a 1 holds its place. So this function simplifies to 1 over x minus 2. So if you do have to simplify this function, this is an example of one where you must do the domain first. Because notice, if you wait, you're going to lose that 4. So if you do have to simplify, domain must come first. That's why we've always done the domain first, is because every now and then you will wind up with a function where something divides out. So if you saved your domain for last, it's going to be technically wrong. So just be careful with that idea. All right. The rest, I believe, yes, the rest are you try it's. So they're worked on the completed notes if you want to check them.